Is this the location?
Affirmative. There should be an entrance nearby.
And the system's in there?
Why don't you go inside and find out?
There it is. Piece of cake.
Easy, Agent. Don't get too confident. Your mission isn't over yet.
Really? It's just me, the computer, and the key.
I wouldn't be too sure about that.
Huh?
Not such a piece of pie now, is it?
I said tape, you idiot! Ah! Ah! Every time!
Looks like we're gonna be here for a while.
What's that?
Oh.
Works like a charm.
Ah, hello Agent. If you're watching this recording, then I suspect that your mission was successful. What I have here are highly classified documents that, if compromised, could destroy our very country as we know it. So, the information which I will debrief you on today: application software. Now, application software, and software in general, is a highly varied and nuanced topic which is highly complicated. I will attempt to break it down for you today.
I don't even know what a computer is.
So to begin talking about this subject, we first need to talk about computer systems. Computer systems are made of both hardware and software. Hardware refers to all physical components of a computer, and software is a generic term for computer programs. It can be broken down into the broad categories of application and system software. Application software is the broadest group of software that there is. It is software that is designed to handle specific tasks for users. There are a range of common types, for example, word processors, databases, browsers, and graphics manipulators. They can be generic programs, which have no narrow goal and could be used in a variety of applications, for example using a word processor to make a poster as well as writing a letter. And this makes them the most commonly used type of software that there is, due to their great level of versatility. Specific applications often have very highly specialized and bespoke usage. Normally, a specific application is only installed on systems where it is directly needed, unlike some generic applications like word processors, which are found on the majority of personal computers. Libraries are ready compiled and tested programs that can be run whenever needed. Most programming languages have extensive libraries of pre-built functions. Someone utilizing Windows operating system can call dynamic link libraries. These libraries contain subroutines written to carry out common tasks on the operating systems, for example, save as. They come with many positives and negatives. An example of positives is that they are quick and easy to hook into your own code, they are pre-tested, and they are pre-compiled. However, negatives include adding functionality or making specific tweaks can be difficult, and sometimes one has no idea how efficient the routine is. As well as this, you have to trust that the developers will continue to maintain the library. Linkers are responsible for putting the appropriate machine addresses in all the external call and return instructions. This ensures that all modules and external library routines are correctly linked together within your code. Linkers can use two methods to achieve this: static linking, in which all the required code from the libraries is included directly in the finished machine code. This can result in large .exe files. And dynamic linking. The required libraries and code is stored on the host computer, and the operating system links these as the program is running. Loaders are the part of the operating system that loads the executable program file into memory, ready to be run. When using dynamic linking, it will also be responsible for loading the required libraries into memory. This can be seen here and here.
He's so handsome.
Now, Agent, we have had our crack team of analysts working tirelessly round the clock, crunching the numbers, and this is the data that they've come up with. So as you can see here, Agent, there is a direct positive correlation. Essentially, the more software there is, the more you apply the software.
Oh, it all makes sense now.
Well, now that we've finished discussing application software, we must now discuss system software. Now, system software is a program designed to run a computer's hardware and applications and manage its resources. There are 4 key features of system software. These are high speed, versatility, difficulty to manipulate, and close to the system.
There are multiple types of system software: the operating system, device drivers, firmware, BIOS, programming language translators, and utilities. Open source software refers to software that is distributed along with its source code, giving any user the right to distribute or modify the software as they please. There are a range of benefits. For example, it can be installed on any number of computers, support is provided by the community, and the creator gets their software out to a larger audience, and of course, the software is free. Some drawbacks can be seen, however. For example, some features lack sufficient testing, it can be poorly supported, and there is very little or no financial gain for the creator. Closed source software, or proprietary software, refers to the software whose author owns all rights to use, modify, or copy it. It is protected by the Copyright Designs and Patents Act, and is often commercially released, and users are unable to access the source code. Similar to open source software, there are a range of benefits. For example, users receive a well-tested, supported, and professionally built product, and creators are able to earn a more stable income from their work. However, of course, there are downsides. For users, there is often a cost or subscription. Creators receive piracy issues and a demand for changes from the community. Thank you very much for listening to this presentation. Agents, now you know everything there is to know about software.
Now I know everything about software.
Interesting.